Hey guys, so today we're going to be starting our chapter, a new chapter called Reflection of Light on Curved Surfaces. So before we start this chapter, we'll recall a couple of things that we'll have learned last year. So last year I had a chapter called Reflection of Light on Plane Surfaces, right? So basically on a mirror. So this is an example of a plane mirror. You should be able to see the camera on the mirror right now. Right, so any mirror or a polished surface has this property that you can look at yourself in it. That is what we call as reflection, right? Looking at your own reflection. We'll quickly run through how that happens, right? So I'm, for the sake of this experiment, I'm going to imagine this piece of paper as a plane mirror, right? Just because it makes it easy to demonstrate, right? So reflection happens something like this. So this is a laser light. So if I try to shine the laser light on this, you'll notice that it has fallen on this mirror and it's reflecting, bouncing off the mirror and falling on the wall, right? So now this is common, it happens all the time, but there is a certain rule that applies when we talk about reflection. To understand that, this flat plane mirror, right, so you'll see that it has two sides, a reflecting side and a non-reflecting side. So in school you should be familiar with this diagram. So they show you something like this. They'll draw a line and then they put something like this, right? That is nothing but a flat mirror. So this side is on the top, just like I placed it here, and this side is on the bottom. So this dashed side, that is the bottom side. Now, whenever light falls on a specific spot, let's say this point, it's kind of like this. So you see a laser light is falling there. This point is what we call as point of incidence, right? So point of incidence is simply a point where the light is going to fall on the mirror. Now something specific to mirrors happens at this point of incidence. So now imagine that this is the mirror that we're talking about. Okay, I'm going to mark my point of incidence with one of these screws. Okay, say the point of incidence is here. Now at every point I can draw something that we call as a normal. Now see, at that point this is vertically straight up. So when we say vertically straight up, I mean to say that this makes a 90-degree angle, kind of like this. If I make the pen stand here, you'll see that it makes a 90-degree angle. So at this point, or at any point in the mirror, we draw this line that we call as N, or normal. So right now this is the normal for my mirror. Now, at the normal, what happens is, assume that this thread, just like the red laser, this is the incident light. Okay, I'm going to assume that, I'm going to put it here, I will assume that this light is incident at this mirror at this point. Yeah, something like that. Now one thing I can notice is, if the light comes like this, there is a certain angle that is being made, right? So if I look at it like this, there is an angle between the nail and the thread, this angle. Now that angle can vary and it can be measured with a protractor, right? So assume that this angle is 30 degrees. What happens in reflection is, if the light comes in at an angle of 30 degrees for example with the normal, it is going to bounce back at the same angle, right? So if it's the light that hits it and bounces back is also going to bounce at the same angle. So even here when it's leaving the mirror, the angle will be 30 degrees. To try to show that in a simpler way, I will do this small activity here. So this is a protractor, right? I am going to place a protractor on the mirror over here. Now I'm going to shine this laser light through the protractor at an angle. I'm going to see how it reflects. So I'll try to shine it somewhere at maybe 60 degrees angle. Trying to make it bounce over here, right? If you I hope you're able to see that there is this red line going through 60 to the mirror. Now once it hits the mirror, you'll see that it is going to bounce back in pretty much the same angle, right? It's going to go back through the mirror, through the protractor at the 60 degree angle there. Do you see it? Right? So that is what is called the law of reflection. So if I have a ray of light coming like this in this direction, this angle is what we call as angle of incidence, I. Now once it hits the mirror at the point of incidence, it is going to bounce back in the other direction and it's going to make another angle R over here. So law of reflection says that angle I is equals to angle R. Basically angle of incidence is equals to angle of reflection, right? That is what is the basic law of reflection. The same law also applies to the new types of mirrors that we are going to be studying about in this chapter. For now, just be familiar with the fact that plane mirror, point of incidence, normal, angle of incident ray, reflected ray, angle of incidence, angle of reflection, and these two angles are always equal.